This is the time. And this is the function itself, or the signal itself. When this one is here, as I am showing you, the red one, the whole part. I have the drawing yesterday. I gave you the drawing. So now, if I want to increase, this is the area should be constant, because from here to here is T0. This distance from here to here is T0. The distance from here to here is A over T0, A over T0. In such a way, the area of the rectangle, is just multiply T0 by A over T0. This is the height, A over T0. Multiply by T0 will give you the area A. واضح شباب؟ Is it clear?
Yes.
Now we have this one, Shabab. I just want you to concentrate with me. Now I have, this is my time axis, and this is my function A over T0, A over T0 here. And now this was my original area. Now if I want to decrease the time, I will increase the area, the height. And then I will do this, and then I will do this. So the time from here to here, and from here to the origin, or from here to the origin, will decrease. If the time decrease, the area, the height will increase. The height will increase like this to save the same area, to have always the same area. So when the time goes to 0 here, the area goes to infinity. And this is known as the impulse. The impulse is a huge force generated on a small amount of time. We call it the impulse. الفكرة واضحة شباب? Is it clear?
Yes, clear, sir.
Is there anyone who ما عنده وضوح في الفكرة هذه؟
دكتور.
Yes.
الآن وش يمثل الواي اكسس؟ الاكس اكسس يمثل التايم، لكن الواي اكسس يمثل وش؟
يمثل السيجنال حقك، يمثل السيجنال حقك، يمثل السيجنال. يمثل السيجنال.
اوكي.
السيجنال اللي هو y of t. Can you see this signal now? You cannot see it, huh? So just 1 minute, because I wanted to give you just one. It has gone. Sorry, I'm looking for a blank sheet so that I will draw a good. Yeah, here. I will repeat what I have said before. This is the time. Here, this is what we have. This is the time. And this is your function, or y of t, or u of t, the signal. Everybody see what's going on here?
Yes.
Yes.
So from here is a over t0, the height. And the distance from here to here is t0. Now, if I decrease the time, I should increase the magnitude. So the area will be the same, always will be the same, like this. So this is T0, new one. So if I decrease T0, I should increase this one. So I will keep the same area, and so on. I will keep decreasing the time. So if I keep decreasing the time and conserve the same area, means I will increase the height. صح? Is that right, Shabab? So until the time goes to 0, the time is becoming smaller, smaller, and smaller. When time goes to 0, you will see many textbooks use this arrow, like something like this arrow, like this. This means this is an impulse written that delta t impulse at time t is equal to 0 with the magnitude, whatever your magnitude here you put, a or 1 or whatever. So as time goes to 0, this delta t becomes huge or force or whatever it is. So we call it the impulse. So the impulse is simply the special case when the time goes to 0. So now we need to find Laplace transform for this one. This is the when time goes to 0. The area is this one, and the definition is this one. We can do the same thing, Laplace transform, either by using the integral or by taking the limit. If you remember, we already gave you the Laplace transform for the pulse. Laplace transform for the pulse, we found it last time. We found this one is Laplace transform for the pulse. Now, if we take this, if we take the limit for this when time goes to 0, we will find Laplace transform of the impulse. So this is Laplace transform of the pulse function, pulse. الإمبulse يعني اللي هو delta t impulse is when t goes to 0, the limit when t goes to 0. Now we take the limit of this one when t goes to 0 here, we will find the following. A 1 minus exponential minus t0s over t0s here. This will turn to find the limit of this guy. Now, if we take the limit when t0 goes to 0, what will happen here? This will be 0. The denominator will be 0 here. And exponential minus st0 will be 1. And 1 minus 1 is 0. So at the end, we will have 0 over 0. As you can see, it's 0 over 0. 0 over 0 is undefined. So we will use what we call L'Hopital rule. Because we have 0 over 0, we call L'Hopital rule. L'Hopital rule says you need to find the derivative of the numerator over the derivative of the denominator when t goes to 0. When you take the derivative of the numerator, this one, when you differentiate it with respect to t0, you will find a as a constant, and this one will be s exponential minus st0. And t0s, when you differentiate it with respect to t0, this will give you s. So this is the derivative of this one. Now, if we take the limit, you simplify here s with s, and when you take the limit when t0 goes to 0, this will go to 1. So 1 times a will be a. So the limit of the impulse is a. Impulse of magnitude a is a. If the impulse has a magnitude 1, usually it's written like this. If the magnitude is 1, so delta t will be equal to 1. Laplace transform of delta t will be equal to 1. Laplace transform of an impulse of magnitude a is a, and so on. So these are the properties of Laplace transform, as you can see here for delta t, since delta t is written like this. Usually you find in your textbook that it is written like this here at d, it's delta t. So this one will be delta t, and this one is t. So delta t minus t0 is everywhere is 0, except at time t is equal to 0. So here it is 0, and here it is 0. Let me change the color so you will understand better. So the first one here, if you look, it's 0, everywhere 0, except at time t is equal to 0. The function is 0, except when time is different from t0. Always 0. 0 here and 0 here. Delta t minus t0 is equal to infinity when t is equal to 0. Meaning to this one will go to infinity here. A huge force, a huge magnitude. And the integral of from minus infinity to infinity of delta t minus t0, it will be always equal to 1. Here, this drawing is for delta t when t starts from 0. Now I will show you this one here. when the time is start little bit later, like we did last time. So we can draw this impulse like this. So here, t is equal to t0. And your impulse is here now. This is your y-axis is here. And now this one, we call it delta t minus t0, because it's starting little bit late. It's starting at time t is equal to 0. So we define this one as the impulse that is shifted by time t is equal to 0. Here, all here is 0, as you can see. Delta t minus t0 is equal to 0 when t is different from t0. It's 0 here and 0 here. Delta t minus t0 is equal to infinity when t is equal to 0 here. So it goes to infinity. And then integral of delta t minus t0, this one will be equal to 1. This is known as the impulse. So this, the physical meaning is you generate a huge force in a small amount of time. The sinusoidal function or cosine and sine are similar. They are defined as 0 before t is equal to 0. And then you have your sinusoidal function that is written like this, sinusoidal curve here. So we need to find Laplace transform of this one. To find Laplace transform of this one, it's better to deal with exponential functions. What do we mean by exponential function? It means there is an Euler formula, Shabab. It's called Euler formula. And we can write the sine and cosine, we can write them in terms of the e to the power j omega t, which is equal to cosine omega t plus j sine omega t. This is in defined. Maybe you have you saw it in your course Math 202 also. So we define.
I have a question about the previous slide.
تفضل.
Here,
تفضل.
dt minus dt0 equal to 0. What's the meaning of that? I didn't understand. I understand what you explained before the slide before, but here it's not clear.
حاضر.
تسلم الله يجزاك خير يا دكتور.
شوفوا شباب here السيجنال ما كان في سيجنال قبل التايم تي از ايكوال تو 0 لانه اتس ا هيوج فورس. نفرض انه في فور اكزامبل لا قدر الله في قنبله انفجرت الساعه 1 بالضبط مثلا. جاست ان اكزامبل، دونت تيك ات انه صحيح هذا الشيء، ما هو صحيح. قنبله انفجرت على الساعه 1 بالضبط. 1 القنبله انفجرت، صار هيوج فورس here. Let me just try to visualize it for you. You will understand it. البن هذا تاعي it's creating trouble for me. Let me use the mouse directly here. So this is my axis. This is the time, and this is time t is equal to t0. Before t is equal to 0, this one was 0. Magnitude is 0. Nothing is happening. That's why it is 0 here. When
it's
t
here.
And it's here also, it is 0 here. Imagine that a bomb explosion, we had explosion at 1 بالضبط, at 1 o'clock. Before 1 o'clock, there was nothing. At 1 o'clock, الانفجار صار هنا, the explosion صارت هنا, a huge explosion here, and then in a matter of second, خلاص, راحت الاكسبلوجن وصلت للزيرو. So this is the meaning of it, what it is. And then delta t at t is equal to t0. At t is equal to 0 راحت الانفينيتي, huge here. And then the integral we said always is the area. The area when it is unity, it's always equal to 1. This integral is equal to 1. I hope this one clarifies.
Yes, yeah.
So for the side Shabab, usually these are also terms that we can see in the physics of the problems. E to the power, the sine omega t, we can express it in terms of sine, in terms of the exponential term. So we define the Euler formula. الأيلر formula شباب, how it is defined, e to the power j omega t, e to the power j omega t is equal to cosine omega t plus j sine omega t, where j is equal to square root of minus 1. Square root of minus 1. E to the minus j omega t will be cosine omega t minus j sine omega t. Now, Shabab, if we add this together, this plus this, so equation 1, this is equation 1, and this is equation number 2. If we add them together, 1 plus 2, if we add them together, as you can see, this and this, they will cancel. So we have 2 cosine omega t. 2 cosine omega t will be equal to a to the power j omega t plus a minus j omega t. These are 2 cosine omega t. So if you want only cosine omega t, divide by 2. And this is how we can, if we add them, we find the cosine term. Now, if we subtract 2 from 1, we will find the sine omega t, which is this one. So this is the expression of the sine, and this is the expression of the cosine. Now, to find the Laplace transform of this, we will find Laplace transform of this. And to find Laplace transform of this, we will find Laplace transform of this one. It's very easy. Just follow the integral or the exponential function that we gave you before. It's exactly the same case. So if you follow the normal procedure by taking the integral, a sine is expressed in terms of e to the power j omega t minus a to the minus j omega t times the kernel, which is for Laplace transform. You arrange the exponent here and here. And at the end of the day, we found this a over 2j, 1 over s minus j omega minus 1 over s plus j omega. You multiply by the complex conjugate, so you will not have the complex number in the denominator. So you end up by having this expression here. So s will cancel with s, and you will have 2j omega over a over 2j, s squared plus omega squared. 2j will cancel with 2j, and you end up by having a omega over s squared plus omega squared. So Laplace transform of this a sine omega t will be a omega over s squared plus omega squared. Similarly, in the same way, we will find Laplace transform of the cosine omega t in the same way, just by introducing the 2 terms of the cosine in terms of exponential terms. So remember, Laplace transform of a sine omega t is a omega s square over omega square. Laplace transform of a cosine omega t will be as over s square plus omega square. So you are not required, Shabab, to sum them by heart. You can use the table. You can use the table. The table in. By the way, at the same time, I have good news. Good news is that is this. Textbook will be available next week. Online textbook. E-book will be available next week. I'm not sure if you are aware of it or not.
No, we are not.
So e-book will be available next week, inshallah. The university told us, or the chair yesterday, we had a meeting. He told us that the textbook will be available next week, and you will be, inshallah, in a very nice picture, inshallah, بإذن. So now we are not requiring you, شباب, باش تحفظوا some هذول Laplace transform. All you need to know is you can use the table. The table is in page 2.1, page 18, 19 in your textbook. And you can see what we have seen so far. This is the function f of t. This is Laplace transform for it is 1. Unit step delta t, Laplace transform is 1 over s. Ramp input t is 1 over s squared. When we have a function of this one, t to the power n minus 1 over n minus 1 factorial is 1 over s to the power n. E to the minus at is 1 over s plus 1. T over exponential minus times e to the minus at is the same as t, but it is shifted, so you need to multiply it by s here, you change it by s plus a because it is shifted. So here t t. Exponential minus at turns out to be, you change s to s plus a, and so on. So sine omega t will be this, cosine omega t will be this, sine hyperbolic will be this. So you can use the table directly. But Shabab, you have to, when you use the table, رائد تفضل.
دام فضلك يا دكتور، يعني يا دكتور ما يحتاج نحفظ الديفينيشن في الاختبار، يعني لما نبغى نطبق على طول بدون الديريفيشن حقها حق الانتجريشن.
لا you don't need it, you don't need it شباب, you don't need it. Okay, you don't need it. You have the table, you have MATLAB, you have everything. Okay شباب. Since I mentioned that you have to be careful شباب, because what is happening exactly here, if we go back to the table, when we do the integration of Laplace transform, this one, when we do the integration of exponential minus st, this integration 0 infinity exponential minus st dt, this guy, whatever it is here, f of s, whatever it is here, you have f of t. So when you substitute by infinity, e to the minus infinity is equal to what? 0. And e to the minus 1, e to the 0 is equal to 1. So this is from, because e to the power 0 here, and this is e to the minus infinity 0 here. So you have to be careful. The table is given from 0 to infinity. The table here is given from 0 to infinity. You cannot always apply the table. For example, for this case here, you cannot apply the table. Why? Because the function is defined from 0 to 4, and then from 4 to 7, and then from 7 to 9. So this should appear here. When we do the integration, we will integrate from 0 to 4 plus the function from 4 to 7 plus the function from 7 to 9, and then plus from 9 to infinity. From 9 to infinity. When you substitute e to the power 4, it stays there. When you substitute e to the power 7, it stays there. When you substitute e to the power 9, it stays there. So we have to be careful. So the integration will be a lengthy one to find Laplace transform of this function, but still we can use the step function. The step function, we will take it one by one. The magnitude of this is the 0 line. This is the 0, y x-axis is the 0 line here. So magnitude meaning, what is the magnitude, Shabab, from here to here? Is 2. So we can say is 2, it's a step function that starts at 2 ut minus, it stops at 4. So 2 ut minus 4, this is the blue one. And then plus, if you see the amplitude from here to here is 5. From here to here is 5. I will say 5, magnitude 5. It starts at 4, ut minus 4, minus ut minus 7. So this one is the red one. The red one is here. The last one, and then from here to here, the magnitude is how much, Shabab? The magnitude here, the green one, as you can see, the green one is minus 1. So minus 1, it starts at 7, and it ends at 9. ut minus 7 minus ut minus 9 here. And then plus, from here to here, the magnitude is 1. You can write it plus ut minus 1. Every color is with the line. Every color is with the line. Blue is blue. Red is red. Green is green. Black is black. So you can write it like this. You add them together as you can arrange them if you want. Now we will do the following. 2 is here. 2 is here. Laplace transform of ut is 1 over s. Now this one is 3. 3 is here. This is a step function shifted by 4. Step function is 1 over s. Since it is shifted by 4, it will be exponential minus 4s. And then this one is minus 6. Its step function minus 1 over s, exponential minus 7s, plus 2 here, exponential minus 9s over s. Now you rearrange, you can take 1 over s common, and this will be your Laplace transform of this one. Still, you can do it with the integration, as I have mentioned before. You can say this one will be 0 to 4 to exponential minus ts, exponential minus ts from 0 to 4 minus s, dt, plus from 4, the magnitude is how much in Shabab? 5. Integral from 4 to 7, and then plus integral from 7 to 9, and then plus integral from 9 to infinity. So you can do either this one, but this one is much faster than the integral of this one. So this is when we have piecewise functions or step functions that are given like this. We cannot apply here the table. That's why I'm giving you this. You have to be careful. You can also use the properties of Laplace transform. They are available in table 2.2. This is also some properties. Linearity, usually we use the linearity when we have a function given by alpha 1 f1 plus alpha 2 f2. Laplace transform for it is just take alpha 1 f1 of s plus alpha 2 f2 of s. This is called the linearity function. The time delay or translated function, you have a function f of t is given at time t is equal to 0. And the same function, but it is shifted with time when t is equal to tau. It starts at tau, the same function. So the time delay function, just take Laplace transform f of s and then exponential minus tau s. So this one has Laplace transform f of s. This one will be the same f of s, but because of the delay, we multiply it by exponential minus t tau s. So this is Laplace transform for it here. This is exponential minus tau s, f of s. Because of the tau, time delay, it should appear here as exponential. This one, it starts at time t is equal to 0. This is an example. If you want to apply this one, you shift it. So exponential minus 0.5 t minus 4, this one starts at 4. So this is a step function. This step function, it starts at t is equal to 4. So we have exponential minus 4s, okay? And then s plus 0, 5. So multiplication by exponential minus alpha t, if you have a function exponential minus alpha t f of t, just take f of s plus alpha. As an example, we just have seen the Laplace transform of sine omega t is omega over s squared plus omega squared. So Laplace transform of exponential minus alpha t sine omega t will be omega, and s will be substituted by s plus alpha. So s will be substituted by s plus alpha. This is for the sine. For the cosine, if you see the cosine, Laplace transform of the cosine is this. We substitute every s by s plus alpha here. S plus alpha, s plus alpha. So Laplace transform of exponential minus alpha t cosine omega t will be f of s plus alpha. Since f of s here is s over s squared plus omega squared, I substitute every s by s plus alpha, s plus alpha. This is called the multiplication by exponential minus alpha t. The integral, which is the differentiation here, when we have a differentiation, Laplace transform of the differentiation, when we differentiate the first derivative, is just s f of s minus f of 0, where f of 0 is the initial condition, initial conditions. So when you have function f of t, and you take the differentiation for it, in time domain, just you have df over dt. In s domain, f of s will be s times f of s minus f of 0, the initial conditions. So Laplace transform of the first derivative will be this one. As an example to that, Laplace transform of d over dt cosine 2. So according to this, we need to multiply s by s. This is s. F of s cosine 2t minus f of 0. F of 0, this is f of t. When t is equal to 0, this one will be equal to 1. This is f of 0 or cosine of 0. So what is Laplace transform of this one? It's simply cosine. Since it is cosine, so it will be s times s squared plus 4 minus 1. So after manipulation, you will find this one will be simply minus 4 over s squared plus 4, or simply Laplace transform of minus 2 sine 2t. This is the Laplace transform of the first derivative. Usually we write it like this. Laplace transform of the first derivative x dot. Usually the time derivative, we call it x dot. S, x of s minus x of 0. The initial condition, at time t is equal to 0, what was the initial condition? Similarly, the second derivative will be like this. Will be s square. It will be s square here. Hina shabab, s square, I don't know, this pen is not really. S square minus f of s here now, we have minus s f of 0 minus f prime of 0. So this is the second derivative. When we have the second derivative, this is Laplace transform for it here now. We take the Laplace transform of the second derivative like this. S square f of s, to multiply the Laplace transform of f by s square, and then minus s f of 0, and then minus f dot of 0. Usually f dot of 0 is the velocity, and this is the displacement. Since it is a second order system, this will be the velocity at time t is equal to 0, this one, and this will be the displacement at time t is equal to 0. Small example before I finish this lecture today is giving you 3x double dash plus 5x dash plus 7x is equal to f of t, and he's asking you to find Laplace transform x of s of x of t. What we do here, this is a differential equation. We have the initial conditions. We take Laplace transform of the first or the second derivative here. 3, this is normal 3 number. Laplace transform of the second derivative, x double dash. It will be s square, x of s minus s x 0 minus x dot of 0. Plus, this is Laplace transform of the second derivative. Plus 5 here, 5. Then we have x dot. X dot will be s, x of s minus x of 0. Laplace transform of x dot. And then plus 7 x. Laplace transform of x will be x of s. Equal, Laplace transform of the right-hand side will be f of s. Now, Shabab, we rearrange, we have 3s squared. Well, let's take x of s common, x of s from here, and from here, and from here also. So we'll have 3s squared, plus 5s, plus 7. This is x of s. And then we take x0 common, x0 from here, and from here. So we have minus 3s, plus 5x0, and then we have minus 3x0 is equal to f of s. Now we can solve for x of s. X of s alone, we solve for it. You will find it that it is f of s divided by this term, which is f of s here, divided by this term. And this one will be 3s plus 5x0 plus 3x0 divided by this. So if you see this one, if you see the solution of this one, we have two terms. One term that is due to the forcing, to the force, because we have F in the right-hand side. So this one is due to the force. And this one is due to the initial conditions, because here now we have the initial conditions. We have x0 and x dot 0. You can substitute x0 is equal to 2 and x dot 0 is equal to 4. And so this is, if you remember when you were studying the differential equation, you were saying that this is the homogeneous solution. This is due to the initial conditions. And this one was the particular solution. Laplace transform, take this into together. مرة واحدة. In once, you will solve the whole problem. It will give you the initial conditions, that is due to the homogeneous part, and this is the forcing term that is due to the particular part. Laplace transform solves them just in one shot. So this is the solution for this equation, x of t. Still later on, we will solve for x of t. We will try to find what is the function in time domain, which gives you the inverse Laplace transform of this one. واضح شباب؟ The integration, when we have integration, any question? For the integration, شباب, if you have Laplace transform of the integral f of tau d tau, just take Laplace transform of s and then divided by s. So Laplace transform of the integral will be simply f of s over s. Integral will be f of s over s. Now we know Laplace transform of a tau d tau. A tau is simply a ramp input, ramp function. Laplace transform for it is a over s squared. We divide it by s, we will find a over s cubed. This is, Shabab, we call it the final value theorem. What is the final value theorem? The final value theorem says limit of f of t when t goes to infinity is equal to limit s f of s when s goes to 0. In many occasions, Shabab, we have f of t. We don't know what is f of t. The limit we don't know. We have a function, we have a behavior of a function that is like this. This is a time domain. But we do not have the expression, or maybe the expression is complicated when t goes to infinity. This is f of t. Sorry, and this one is simply t here. This is t. And you don't know the expression when t goes to infinity here. What will be this limit? The final value theorem says instead of calculating this when t goes to infinity, is just take a limit of s f of s. Yani take f of s, Laplace transform of f of t, multiply it by s, and then take the limit when s goes to 0. This will give you exactly this one. And this is called the final value theorem. Final value theorem, FVT, final value theorem says the limit of f of t when t goes to infinity is exactly the same as limit s, f of s when s goes to 0. Now we have f of s here. Just we multiply s by this one, and we will find the limit of f of t. Here he is asking you to find the limit of f of t when t goes to infinity. So just we need to multiply s by this expression. When we multiply by s here, by s, this is what we got. So we simplify this s with this s, and then substitute when s goes to 0, this will be 0, this will be 0, and your limit will be 5 over 2. 5 over 2 is the limit for this system. The initial value theorem also is this one, is the opposite. Sometimes we have our function here like this. This is t, and this is f of t, but we don't know what is the limit at time t is equal to 0. Our function is doing this, but here we don't know what is this limit, exactly the limit here. We don't know what is the limit. This is called the initial value theorem, IVT. The initial value theorem says take the limit of s, f of s, when s goes to infinity. And you are done. So the limit of f0 is simply equal limit of s, f of s, when s goes to infinity. If you have an expression of s like this, so to calculate f of 0, or the limit of f of t, we just calculate this limit when s goes to infinity. When we multiply by s here, we can simplify this s with this s. And then, can we simplify, Shabab, here? Yes, we can simplify s with s. And then, since s goes to infinity, we see the higher power of this one. This turns out to be 5s squared over s squared. You simplify s squared with s squared, and the limit will be equal to 5.
Doctor, here we have s cube. Is it a
Any
typo?
mushkila, we can simplify it. You can say this will simplify with this. Or you can simplify it from here and take this with this. You take the highest power on the numerator over the highest power over the denominator when s goes to infinity. You remember this? When s goes to infinity,
Now clear. Yeah.
highest power of the denominator over the highest power of the denominator.
دكتور يعني نضرب الأقواس عشان
عاود سؤالك الله يرضى عليك.
في نفس المثال هذا نضرب الأقواس وناخذ أعلى الهايست باور.
تضرب الهايست باور of s cubed. شوف, this one turns out to be 5s cubed over s cubed. Okay? Or if you simplify this with this, تطلع لك 5s squared over s squared. The limit will be the same.
And if the denominators have more power, it will be 0, doctor. Isn't it?
Yeah, of course. Yeah, of course. Yeah. Just take the highest power of the numerator over the highest power of the denominator. بس هذه when s goes to infinity only. S goes to infinity. واضح؟ هنا شباب, if you see this one, the following expression represents the displacement of a vibrating system or a structure or whatever. We have this. We try to draw this one. We found this. And then the limit of this function here, as you can see, at time t is equal to 0, it's clear that this value is 0.25. صح? Limit of y of t when t goes to 0 is 0.25. هنا. And the limit of y of t when t goes to infinity is 0. This is by using MATLAB. Now we will see how we can use the final value theorem and the initial value theorem. If we use the initial value theorem and the final value theorem, we should end up by having the same values. Limit solution, the final value theorem, limit s y of s. This is y of t. So y of s will be simply this one, 0.25. This is a cosine term, but it is shifted with 2. So replace every s with s plus 2. So s plus 2 over s plus 2 squared plus 3 pi squared. So limit of y of t when t goes to infinity, this one is 0. This is in time domain. We find it in time domain because when t goes to infinity, this term will be between plus and 1, and this one will be 0. So 0 multiplied by this one will be simply 0. Now the right-hand side, which is this one, if you substitute s is equal to 0 multiplied by s, and then substitute by s is equal to 0, you will find in a 0. This is s multiplied by 0 multiplied by anything here will be equal to 0. So the two limits are equal. This is using the final value theorem. By using the initial value theorem, we will find the same thing. Limit of t when t goes to 0. Here, if you substitute t is equal to 0 here, this one will be 1, this one will be 1, and this one will be simply 0.25. When you substitute when s goes to infinity here, substitute, you will end up by having the highest power of the numerator over the highest power of the denominator. Here you have S times S will be S square, 0.25 S square. And here you have S square. So S square simplify with S square. This will give you 0.25. This will give you 0.25. And the same limit. So this is when we find the initial value theorem, and this is for the final value theorem. I think time is over now. This is how another example. Yeah, this one, another example. I will close here. Let me just take the attendance and wish you a very good afternoon, inshallah. Okay, شباب, let me, if I call someone يقول لي يكتب لي حاضر ولا يقول لي يس، يقول لي يس هنا. العلوة موجود؟ العلوة. العلوة بارك الله فيك، شكرا. كنت معنا طول الحصة شباب؟ الديغالبي موجود؟ الديغالبي
دكتور موجود.
اكتب لي يس، اكتب لي يس ابغى اشوفها.
اوكي ان شاء الله.
شكرا. المسعودي موجود؟ حاضر، شكرا المسعودي، شكرا بارك الله فيك. الملا ماجد موجود؟ الملا ماجد، ما شاء الله ماجد، كيف حالك يا ماجد؟ هاني حسين، هاني حسين، ما شاء الله. حسين كيفك يا حسين؟ ما سمعت صوتك اليوم حسين. المحمدي موجود؟ اهلا وسهلا. محمدي موجود؟ اهلا، ما شاء الله. متنكر بالنظارات يا محمدي، ليش متنكر لابس نظارات كذا؟
بس مزين شكلنا شوي.
في الصورة مو الصورة.
ايه عارف.
اليحيى عباس. ما ادري شباب، انا حطيت قبل شويه حطيت كاميرا بس كانه الصوت راح. I don't know. صحيح؟ الصوت باقي شباب؟ والكاميرا تشوفوها؟
ايوه الكاميرا كنا نشوفك من اول يا دكتور.
من اول كنتوا تشوفوني؟
لا بس المره هذه.
لأنه يا دكتور لو احط اسمه الكاميرا اخاف الصوت يروح. طيب شباب خلينا نكمل. اليحيى موجود؟ اليحيى
موجود.
اهلا وسهلا، كيفك يا اليحيى؟ ان شاء الله بخير.
الحمد لله.
عبد الكريم موجود؟ اهلا وسهلا عبد الكريم، نور عبد الكريم اليوم ما شاء الله عليك. عبد الكريم قلنا موجود. الشهري علي موجود؟ الشهري علي اهلا وسهلا. الرميح هاني كنت موجود من قبل صح؟
صحيح.
القرني علي موجود؟ القرني علي اهلا وسهلا. زهراني فارس يا فارس، الزهراني يا فارس. نشوف بعدين حكايه الزهراني هذا. الحمدان عبد العزيز، الحمدان عبد العزيز اهلا وسهلا عبد العزيز. القحطاني خالد ابراهيم، القحطاني خالد ابراهيم. الشريده